Welcome to EC 0442 Study Session 7, Markov Chain Process, Probability Transition Matrix. Introduction. There is no doubt that you are familiar with the matrix as learned in your EC 0104. The main difference between probability transition matrix and the usual one you are familiar with is that the elements of the probability transition matrix are probabilities. The probabilities represent the probability of one event following another event, or better still, the probability of the transition from one event to the next. In this lecture, you will learn how to use the Markov chain process to forecast, for example, the future change in market share of a product in the market. Objective. At the end of this lecture, you shall be able to formulate and solve a probability transition problem to forecast future states as well as equilibrium state of the process. A. Nature of probability transition process. This technique is useful when we are interested in how a random variable changes over time. For example, we may want to know the way the market share of a particular product changes over time. The time may be weeks, months, years as applicable. The technique has useful application in marketing, finance, accounting, production, and education. A classical application is the investigation of brand switching in marketing. For instance, example 1, assume that two products X and Y currently share the market with shares of 60% and 40% each respectively. Each week, some brand switching takes place. Of those who bought X the previous week, 70% buy it again, while 30% switch to Y. And of those who bought Y the previous week, 80% buy it again, while 20% switch to X. We can represent the above transition process as follows. We can present what is in the diagram above in tabular form as follows. And finally, the matrix presentation of the above transition probabilities is as follows. Two, first order Markov process. We assume that the condition or state of the system in any given period is dependent only on its condition in the immediate period and the transition probabilities. where the probability of the next event depends upon the outcome of the last event. The Markov process is termed a first-order Markov process. A second-order process assumes that the customer's choices next month may depend upon their choices during the immediately preceding 2 months. Similarly, a third-order process is based on the assumption that the customer's choices depend on choices made in the preceding 3 months. 3. Constant transition probabilities. The transition probabilities are assumed to be constant over time. This assumes that the system has settled down so that the switching among different brands takes place at the given rate in each time period. 4. Uniform time periods. The changes from one state to another take place only once during each time period, and the time periods are equal in duration. In our example, we assume that customer changes their choice on a monthly basis, and accordingly, the monitoring of the system is also done on a month-to-month basis. C. There are 2 inputs in a Markov process, which are transition probabilities and the initial conditions. Transition probabilities. The transition probabilities are required for obtaining any types of predictions we desire. The transition probabilities may be presented in the tabular or matrix form, but the matrix presented is central to the solution. In general terms, the transition probabilities matrix, where there are n states in the system, can be represented as follows. See table. Note that the sum of the rows shall be equal to 1. For example, the initial conditions. The initial conditions describe the situation the system presently is in. The initial condition in our earlier example was 60% and 40% for X and Y respectively. D. Outputs of a Markov process. There are 2 predictions which a Markov analysis provides. These are the probabilities of being in a specific state and that of equilibrium state. Specific state probabilities. To find the probabilities of being in a particular state, you will multiply the initial condition with transition probability. This process can be repeated indefinitely, but usually you will find that after several cycles, the value will stabilize within a restricted range. Steady state probabilities. A significant property of the Markov chain is that the process tends to stabilize in the long run. A stabilized system is said to be in a steady state or in equilibrium. At equilibrium, the system's operating characteristics is independent of time. The phenomenon of equilibrium can be expressed symbolically as Q bracket K equals to Q bracket K minus 1, so that the start probabilities in period K are the same as in the previous period. E. Example 2. Using the information in example 1, 2, predict the market share of products X and Y after 1 week. Work out the market share of products X and Y after 2 weeks. Determine the equilibrium market share of products X and Y. G. Example 3. Suppose there are 2 types of brands of detergent, Omo and Clean, selling in the market in the beginning of the year 2010, when a third one, Bonus, is introduced in the market. A month-by-month observation of the changes in brand loyalty revealed that each month customers are being drawn from Omo to Clean to the extent of 30%, 10% drawn to bonus and the remaining 60% staying with OMO. However, 20% of those using clean in a given month are drawn to OMO. One half of them do not change their brand, while the remaining 30% shift to bonus. Similarly, the behavior with regard to bonus is found to be like the 80% of the customers stick to the brand. 50% shift to OMO, while the remaining 5% shift to clean. Given that the market share on March 1st is 30%, 45%, and 25% for OMO, clean, and bonus respectively. You are required to 1. Present the brand switching behavior in a diagram. 2. Construct the table of transition matrix for the problem. 3. Construct matrix P and matrix Q, bracket 0. 4. Briefly explain the elements of matrix P. 5. Calculate the likely share of the market on April 1st. 6. Construct matrix P2 and interpreted its elements. 7. Calculate the probability that a customer who purchased clean on March 1st would purchase bonus on May 1st. 8. Show that Q bracket 2 equals to Q bracket 1 P. 9. Interpret the elements of matrix Q bracket 2. 10. Calculate the steady state market share of the 3 brands of detergent. H. Solution 3, bracket high. The brand switching behavior can be presented in a diagram as follows. See diagram. High, solution 3, bracket high. The table of transition matrix for the problem can be presented as follows. See table. Summary. The probability transition matrix method can be used to investigate the brand switching of a product in the market over time. You can calculate the probability and market share at a particular period as well as the equilibrium market share when the market stabilizes in the long run. End of study session 7. Thanks for listening.